Okay, welcome to lesson 14. This is going to be our last medium lesson, or like is in medium as in like our mediums that we've talked about so far, like painting and drawing and sculpture and craft and all of that. So yeah, let's get right into it. Architecture is the art and science of designing and constructing buildings, not only for practical purposes, but sometimes for symbolic and aesthetic purposes as well. Architecture is definitely one of those that, when you think about visual arts, is maybe not one that you think of initially anyway, because it seems more like an engineering thing. And less kind of separate from the arts. However, architecture is very, very rich in our art culture. And hopefully, when we talk a little bit about why architecture is created for non practical purposes that are symbolic and aesthetic, you can kind of see the connection between the two forms of art. The symbolic and aesthetic purposes and just the art of architecture in general, the goal is always to seek to enhance our daily lives, and just our overall like mood and feeling about spaces. So let's get started with like way back when we first start to see architecture evidence. And this is also, one of the first signs of humans sort of like developing and how, we got to where we are today. The dolmens in southwest England, these are one of our oldest surviving structures. And most likely these were not like a place of residence or places that people like, lived in, but they were more so symbolic. It's the way that they would house the dead. So, going into like what architecture needs in order to be considered architecture, you have to integrate these three issues of function, or how a building is used, form, how it looks, and structure, how it stands up. So really, without knowing that we're talking about architecture here, this sounds a lot like what we have already talked about with, things like sculpture, things like painting and drawing. We've talked about function, we've talked about form, and we've talked about the physics of how, especially with three-dimensional work, you might have an idea about something, but you have to have that more logistical part of like, how is this going to actually exist in my, physical world and not collapse or not fall over. With architecture, there are also, so these are the issues that we have to consider when we're building something like initially. And then when we start to think about the more like practical, like, essential components to creating the architecture, you have to think about the supporting skeleton, the outer skin, and the operating equipment. So the operating equipment was not something that was used initially. Really, our early things like these were really just concerned with like the outside skeleton and the outer skin of it. But the operating equipment like plumbing and electrical wiring, etc., this didn't come until, way later on. It seems like we've had these things forever, but in the span of how long humans have existed, it's only been in the last, 150 years or so that those things have been essential to architecture. um so let's go back into like our early buildings, kind of what evolved from our early architecture, and how, why also that we don't have proof of a lot of the early architecture, thousands of years ago. So initially, our housing is evolved from caves in hunter-gatherer times, where it wasn't really like that we were making architecture, we were just kind of utilizing what was there. And this developed into huts and tents and more substantial structures, like we see in this painting here. We see this is sort of typical of like, right after the sort of cave hunter-gatherer times. Um, the reason that we don't see a lot of this type of architecture anymore is because of the materials that were used to create it. It wasn't things like stone or brick or concrete. It was, sticks and leaves and things that were more sort of biodegradable over time. And that was probably just for like the capabilities that we had. We didn't have huge cranes to move things for us, and all of that. We had, just kind of bare essentials, what we could carry, what we could make, just as being a person. um Another thing that we think about is that we're also in like migration times during this era. And so we don't want to make our structures too permanent, because and spend all this time, because in 3 or 4 months we're probably going to move. and have to pick this up and, build it somewhere else. But that's why things like the dolmens here are really symbolic, and just sort of telling that we're not only interested in creating architecture and creating spaces for our like practical needs, but also for symbolic and religious and more sort of like this other veil of what we needed this for, what we were desiring architecture to be. And we can see how these might be something that's more permanent because these are not going to move, obviously, unlike our like tents and our huts like these that are going to have to be either like packed up and then like carried with us, or just going to have to be left and not used again. So something that's also interesting, I think, during this time, especially when we find like artifacts and like remnants from this type of architecture, there's a lot of regional styles that developed, and that just depended on the materials that we have. So when you think about even today, the influences of architecture that's in India and the Middle East and Europe and Africa, they're all very different because they're coming from different ancestries of what tools and what materials were available to those types of people. We see a lot more like wood and things like that sort of coming from more of like our island countries that don't have like these huge boulders and stones. Like wood was something that was more so sort of like needed and was used for those types of buildings, while as in other places brick and cement and things like that started to develop. So it's just all sort of interesting to how even today our architecture takes influences from our culture thousands of years ago. So let's get into some traditional materials that we see early on. So wood, stone, and brick, these each sort of like start to develop as we start to have things like the wheel that are invented that we can sort of pull things with or make our jobs a little bit easier so we can make more permanence to these structures. Um, so let's talk about wood, stone, and brick. Let's just break those down real quick. We start to learn that certain materials are better for certain parts of the house, whereas other materials are better for other parts of the house or of the building. So the wood kind of becomes more reliant on like the lighter parts of the house, like the roof beams and things that are going to be raised because it's a lighter material, while as heavy stone and brick are used for like more of the load bearing, and aren't very effective as a beam. So we start to, I mean, these are really kind of things that you probably already know now, but you start to kind of like think about a little bit more when we're first making these decisions. We have to like kind of go through this trial and error of like these really heavy stones cannot be used in ceilings because it's going to collapse and then make the house fall in. Most of the world's architecture is composed of stone, though, because of its permanence and availability, and it is just beautiful in general. But the things that remain from thousands of years ago are not going to be the things that are wood or even early brick materials, even. But stone is always going to stay like this. It might kind of erode over time or change a little bit, but it's not going to go anywhere. So going into more of like the methods that we start to see, even here in this example, we start to see this like post and beam method being used where, this rock is being held up by there's two posts right there. Early examples, but let's kind of back up to, I guess, more sort of patterns, I guess, that we start to see. Dry masonry, this is a really common one early on. It's just essentially when you're piling stones on top of one another. And it's called masonry when it's done in a very consistent pattern like we see here. This is, obviously to make a shape and to make form with. It's not just stacking it carelessly and, not in like a particular order. And then when the stones are dressed, it means that they are cut or shaped to fit in a specific position. So you can kind of tell here that all these stones are like relatively the same size. And so they've been sort of like cut or dressed to be, what it needs to be to create this structure. This is the Great Zimbabwe in East Africa that I'm referencing here. Its original function is still very unknown, but probably used to house the dead or, be something that was more for a ceremonial or symbolic purpose rather than like housing or, being a place people actually were like working in or living in. Um, there was no windows because that did weaken the masonry. So these are just, big giant columns here with no light coming in except for maybe like the top a little bit. Um, early examples or more early examples of this type of architecture that's using dry masonry is the Great Pyramids in Egypt, Machu Picchu in Peru, and then Mesa Verde in the southwestern United States. All are using this like very early dry masonry technique. Some more sort of like just material methods that evolve along the way is the post and beam. Very, very early example is what we see here. This is just like, okay, we put these two rocks together and put this one in the middle and it creates sort of a shelter. Um, this starts to get much more complex and it's still being used. I mean, even like, to make the frames for your houses now that the post and beam method is still applied in a lot of ways. The post and beam is where the vertical post bear all of the weight of the horizontal beam and it carries it to the ground. So it creates almost like this seal or like this like this connection or like this form together because of the tension and like the compression of the top load. So this almost creates like a seal or like a glued sort of effect to it when it's made in this way and when the right materials are used also. Um, this is later refined by the Greeks, and we see this in like the Parthenon and other architecture. This is a row of columns or like the post and beams, and it's called a colonnade. There's so many different I could go through these forever, but it's just there's so many developments that come from this that you know created kind of what our architecture is today, and you can see it very, very present in history. So just, I mean, if you're ever like looking at for history or whatever, at different buildings, different locations. Look to see if there's a version of post and beam. It probably will be there somewhere. This is just like a little excerpt. I'm kind of moving a little bit quicker through this. This was a much longer chapter, but I'm just kind of hitting like the main points here. This is a cast iron building, and I'm using this example not for like really an example of how this is a successful material that is used, but more so how it sort of got outdated due to just some safety issues and just issues with the material itself. This is the Crystal Palace, designed by Joseph Paxton. It's glass and cast iron, not as applied as ornamentation, but as the structure itself. It's cast iron was something that was like earlier on sort of popular, but it did show some defects and susceptibility to fires. The buckling of the cast iron is unprotected of unprotected metal struts, and it caused this building to burn down in 1936. So this is one that was, kind of had like a little stint where it was popular and then quickly became outdated. Let's talk a little bit. We're jumping, I know, ahead a long way from like our dolmens and like early architecture we saw there, but I just kind of want to get into how we've evolved from there. This is still in reinforced concrete buildings, and this is what kind of created the ability to create some of these early on multi-story skyscrapers that we see. Yeah. Sorry, y'all. Okay. So, yeah, the multi-story skyscrapers that we see here, I know these are like a really early example, but this is really an example of, how skyscrapers were and how, the possibilities that they had early on. They weren't so much about, the height of it. It was more so just being able to create even like 8 stories or so was really revolutionary at the time. We also see the development of elevators here. They're not electric yet. There's like a pulley system for them, but this sort of, starts that off as well. Louis Sullivan, he's one of the first great American or first great modern architects of our time. He creates these early skyscrapers. This is the Wainwright Building in St. Louis, and the exterior reflects the interior frame. So, a thing about skyscrapers is that it does come from like our industrial revolution, and that sort of like is paralleling with like what's going on socially during the time. The skyscraper buildings wanted to kind of give off this feeling of like order and like, just production, and instilling all of these like more kind of capitalistic ideas that we have early on, about how we want America to be and how we want, just the world to be in a very like, straight order, lots of production happening. And so that's why the frame sort of like, having this grid like system, you can kind of know and understand what's happening on the inside as well. There's always like little office cubicles. It's very divided. Has this very like grid like scheme on the inside as well as the outside. And this is called international style that we see, where it's like, this expressed function of the building is expressed through the exterior as well as the interior. It works on underlying structure. It's very logical. It's very like left brain based. But yeah, this is an early on example of a skyscraper. You can see compared to our skyscrapers today, there's a lot of like ornamentation still in the style, especially up here at the top there. And it just has a lot of personality to it, unlike some of our skyscrapers today that are like this more modern one back here that's just like, reflective glass on the outside. It's doesn't have a whole lot of character to it. Alongside Louis Sullivan, we see artists or architects like Frank Lloyd Wright, who are building with an awareness of the surroundings instead of just placing their architecture in the middle of something and not really considering the space that it's being put in. The Frank Lloyd Wright acknowledges like natural spaces and builds with an awareness of those surroundings. So this is one of his examples here. This is the Kaufman residence at Bear Run in Pennsylvania, and this house, it's a house, is one of the first to use a totally open floor plan. It eliminated the rooms between, or the walls between the rooms, so it was very open, unlike this building here where you can tell there's a lot of like cubicles and like walls that are dividing the space. This is all like one big open floor plan, which is really popular today as well. So elimination of walls between the rooms. He placed windows in the corners to make the space look bigger, and had even like sliding glass doors that are inspired by Japanese screens to make the space feel even more open. I think some interesting things to kind of talk about, especially with like our elements and principles of design here. He's doing things like creating these vertical columns along the house and in the middle of the house to reflect the trees. He's allowing this whole waterfall to like run through the house, and so he's not obstructing the natural scenery at all. And so I mean, you can tell that this is a residence, but like maybe if you were driving past in your car, this might just like blend into the natural like landscape itself. Let's talk about some recent innovations. So this is, this sort of era, this Frank Lloyd Wright era starts to occur in like the 50s, 60s times. But with recent innovations and, how architects can really have the opportunity to play and to kind of push what their opportunities are. We look a lot at places like art museums. We also look at places like the Disney Concert Hall, and where the kind of intention there is to just let the architect have fun, and to push the limits, create new cutting edge designs. And so art museums though are a really great place to experiment with that, because art museums are obviously wanting to showcase art of all forms, including the architecture that it's in. So, having a really plain, still exterior building, it's not as enticing as something like this piece here that's the Guggenheim Museum in Bilbao. And this almost acts like a functional sculpture. The architect called this a metallic flower, and uses a lot of curvature, lots of like, just making this space feel not quite as like grid-like and linear as other architecture sometimes feels. Other like actual material innovations, we've got carbon fiber. This has been around for a while, but the technical advances allow for the weaving of buildings together. We also use carbon fiber for things like aircraft parts, racing car bodies, bicycle frames, etc. And we use it because it's very, very lightweight. Lots of the components can be light enough to be handled by any one person. So, imagine carrying like a huge stone that was the size of like this wall here, like even one of the panes of the wall. Um, couldn't do it alone for sure. But the carbon fiber is very tactile. It's very sturdy, but it can be handled like by a single person or by a few people. It elements on pulleys, so you can just kind of like pull this into the frame. And yeah, this is the BMW Guggenheim Lab. And this is a great example of just sort of showing what carbon fiber has the possibilities of doing, having this really almost like floating building here. And it being a public seminar space where a lot of people are going to be walking around, and it's strong enough to support that. We also see the advancement of cross-laminated timber, or CLT timber. It's a carbon neutral building material. It uses laminated slabs of wood and puts the grains at an angle. It acts as strong as concrete does in some situations, but it's much lighter. It's fire resistant. This is the Radiator Building of Portland. It's one of the largest structures created with CLT, and has vertical accents to it that kind of like make it seem like it's even taller than it actually is. And yeah, it's very, very highly technically advanced, has programmable slats over the windows to sort of like be able to adjust as the temperatures change. It makes it very like eco-friendly as well, to sort of act on like nature's own heating and cooling, rather than having to do that internally. And also has an automated response to earthquakes that are prone to happen sometimes in Portland. So still talking about recent innovations, but kind of like the direction that we're headed with architecture today. Architecture is increasingly trying to reduce its impact on the environment, because architecture can be rather a pretty big pollutant, honestly, by just building irresponsibly or building without consideration of like the materials that you're using, and the just sort of like the production of pollution that will occur from building. We have this organization called the Green Building Council in the United States, and it awards different architects for leadership in energy and environmental design, or LEED is like the award's called. This McSolaire home, created by Michelle Kaufman, is an award winner of this award. She creates this green single family home design. And this is just sort of like a mock-up, or like a model of what these might look like. But this is a kind of solution to the more pollutant like suburbia that we see today, and that was being created more so in like the late 90s, early 2000s, that didn't really know that it was being so much a cause of pollution as it was, by building the way that it was. But these are very efficient insulations, have low flow fixtures. I think have gardens on the rooftops. Use solar panels. Just very, very highly eco efficient. But still, is a product of what a single family home could look like. Other ways of building green, and this is probably my favorite way to sort of like showcase how building green can be sort of create a lot of character within the architecture, and have it give it a lot of sort of I don't know, just a feeling of character. I don't know how else to describe it. Architects rehabilitating old buildings rather than building new. We see this a lot even in like the Belmont area right now. They're converting like old mills into new like office spaces and studio spaces and houses, and all kinds of things. This is the Green Building in Kentucky. And they readapted a 120-year-old store, or like a warehouse store, and then used brick walls insulated with materials from recycled blue jeans to create more, recycled insulation. The flooring of this building is 100% recycled, and it reduced the energy use as well. It uses geothermal wells below, building tapped for heating and air and water. And then it also uses solar panels. So I really like how this looks, how, they're using the old and they're like, building on what was already there, but then also sort of combining this newer architecture as well. It just kind of creates a really good, like cool look, I guess, to see this like old and new coming together. And then I believe this is our last video before moving on to lesson 15, but this is the Earth ships that we see being created in the late 20th and early 21st century, and still even today by this architect Michael Reynolds. He designed to behave as a passive solar Earth shelters made both from natural upcycled materials such as earth packed tires. This is one of the examples that we see here. But I've got an Earthships video that is in our lessons or Ed Puzzle lessons folder that I want you to watch. It's about 30 minutes, but it's really, really important that you watch that for our assignment that is due alongside this lesson as well. So, yeah, give that a watch. I won't talk too much about the Earthships. I'll let Michael Reynolds, who is in the video, talk about it himself. But yeah, we'll meet back here for lesson 15.